blah, 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 blah. That is right of the z equals 1.358 and left of the negative 1.358. Round your decimal to 3 decimal places.
So it wants both tails, or?
Yeah. So I think if you go to the normal probability applet and if you just highlight the left and the right, it'll give you the area.
So I got 0.17 and then it will be 5.
Yeah, that's what I got too.
0.175.
Yeah.
Mm-hmm. You guys are just using the
applet
thing.
Yeah.
Okay.
Yeah.
Okay, question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, the distributions of sample means bar X, or this cannot be determined from the information given.
I think it's the first one.
The distribution drawn just from X.
Yeah, I think, but I'm not positive.
Smaller.
They want to see if the standard deviation is.
Which one will have a smaller standard deviation if 9 observations are randomly drawn from a population?
I'm not really sure if you can.
Well, because if you think of the to find z, or to find oh no, maybe I'm thinking wrong.
Well, I don't think you can determine that just because to see how much the standard deviation is, you have to know the population size.
That's true.
But I am on high painkiller, so I don't know. I don't know if you should trust me. But
what do you guys think, Jared and Luke?
I was kind of, from what I understood from the reading, I was leaning towards B, but Charity makes a good point. If we don't know the population size, then
yeah, because it'll change depending on the how big the population size is or not. So yeah, I think we just don't know from this information.
Okay. Sounds good.
That's wrong. At least we have another shot. Sorry. I told Alexa I'm not with it. Really, I broke my ankle yesterday, so I'm all hopped up on pain medicine. I'm like, yeah.
Yeah. Sorry about that.
Jared, do you want to do number 5?
Let's see. Okay. Number 5. Which of the following results implies that the spread in X decreases as the sample size increases? I thought that was the central limit theorem.
Yeah, I think so too.
Yeah.
I agree. Sample size is large, and the central limit theorem implies that the sample size mean is normally distributed.
All right. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diana earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diana's score? Round your answer to the 3rd decimal place. So the z-score would be Diana's score minus.
I got 1.045.
You're faster than me.
And then, is that just using like the equation of taking like
Yeah, so it'd be 160 minus 150.8 over 8.8.
Oh, okay.
Okay, so we don't have
That
to
makes
do the 8.8 over the, because yeah, that's what I
No,
was looking
because
at. I
there's
was
not
like,
another sample. It's just one person.
okay. All right.
Wait, sorry. What did you say you got?
1.045.
1.045.
That is not what I got.
Wait, so you did 160 minus 150.8 divided by the square root of 8.8,
No, just divided by 8.8.
not the square.
And what did you get?
I got 1.045.
Mine is like way off. I don't know. Hold on. Okay. Something's up with mine. Because I got 142 points.
Well, that wouldn't be a z-score. So did you take 160 minus 150.8?
0.8 divided by 8.8.
Hmm.
Let me try this one more time.
What are you getting, Luke?
Fine. Yeah, that's what I'm getting the same as Charity.
Yeah, I don't know what the heck I'm doing wrong. Cause
Sorry.
So 160 minus 150.8 is 9.2, right?
Yep. And then divided by
And then
8.
divided by 8.8. So it can't be 154, whatever you guys are getting. Sorry, that sounded rude.
okay.
No, you're
All right.
fine.
Does that make
No,
sense?
that didn't sound
160.
rude. So what I needed to do to get the right answer is I needed to put brackets around the 160 minus 150.8 and then
Okay, there we
divide
go.
it by the 8.8. Because if you do that,
I just had to
you get,
separate mine. Sorry.
No, you guys are good.
That was way dumb.
Okay, so then for question 7, we have to put,
so wait,
it's one,
we all got 1.4 or 1.045.
Yep.
All right.
yeah.
What were you saying, Alexa?
So for question
Sorry.
7, you just have to put the z-score in to the probability applet, and then you'll just take whatever's on the right of the right line, and then you'll get your answer.
Okay, I need to.
We're shading to the right.
Yeah.
You put that in the area bar or the
The z-score. All right, and we want the area, right?
Yeah, the probability.
So the probability is 0.48 or 1.48.
Yep, that's what I got.
0.148?
Yep.
Okay, me too. 0.148.
Okay, and then question 8, does someone want to read that?
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What's the z-score corresponding to the sample means of the student's scores? Round your answer to 3 decimal places. Example, if the answer is, okay, blah, blah, blah. So just three decimal points.
So for this one is the one that you would use the square root at the bottom, the square root of 5, because it's the sample of these 5. And so the mean for this too, I already calculated, is still 160. So it'd be 9.2 divided by, in brackets, 8.8 over root 5.
Square root of 5.
And then I got 2.337, but rounded up 2.338.
So wait.
8.8 minus square root of what?
Square root of 5, because there's 5 students.
Okay.
So
All
can
right,
you run through
so-
your calculation one more time?
Yeah,
Sure.
so the mean of this thing is 160, and then you subtract it by the mean of the large group, which is 150.8, and so then you're left with 9.2, and then you divide 9.2 by, in brackets, 8.8 over root 5, because 8.8 is the standard deviation and root 5 is the number of students we're sampling.
Did you get 2.338?
Yep.
Hold on, I'm almost there. All right, so 2.338.
Yep.
All right. So what is the probability of the 5 random selected students?
So then you
will have
put
a
that
mean
z-score
greater
in the
than-
applet.
I got
I wish Shakes to the right again.
0.0097. So
Yeah, that's what I got as well.
The 0.010 then.
0.0. Well, she told us to put it into 4 decimal places.
Oh, and there are 4 decimal points. Okay, so 0.0097. Is that what it is?
Yep.
Okay, 5 more problems.
15
information.
minutes.
Okay, use the following information to answer the next 5 questions. Suppose the mean GPA of the BYUI students is 3.5. Standard deviation is 0.7. It's well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sample distribution of the random variable bar x? Which
So
represents
approximately normal.
Yeah, because of the
Yeah.
central limit theorem.
All right, what is the mean of the sample distribution? So it's the same as the mean of the population, which was
3.5.
3.5.
What is the standard deviation of the distribution of the sample means for all possible samples of a size of 81 that could be drawn from a parent population? Okay. So it'd be 3.5.
The standard deviation is 0.7. Or
No, so
wait, I haven't finished doing it. I was asking what the original
Oh.
standard deviation was.
it's mean of distribution?
Yeah. Oh my gosh.
did you get 0.0778?
How did you get your answer, Alexa?
So you would just take the standard deviation, which was
0.07 or 0.7.
yeah, and 0.7, and then you divide it over square root of 81.
Okay, so 0.0778.
Yeah, so you'd round it to 0.78.
Okay, that's what I got.
Okay.
The square root of
Wait, it says
sorry.
wait. That one just says to run it to 1 decimal point, so it's just going to be 0.1 then, right? On question 11.
No,
Question 11 is 3.5 because the mean stays the same since it's a large sample.
Oh, okay. I was on a different problem. 778.
so 0. Round to 3rd decimal place or 4th decimal place?
Third.
Okay, so it's 0.7 or 0.78.
Mm-hmm. Yep.
Sorry,
You
running
are
behind
good.
today. All right, and what is the probability that the mean GPA of 81 students selected would be less than 3.3? Round your answer to the third decimal place. So that's where we find the z-score and then plug it into the area, right?
Right, and then you'll just take the left of whatever's on the left line.
Okay.
Do you guys get number 13?
Working on it.
We're finding the z-score and then plug it into the applet and then
Yeah.
That's the power of 81, right? All right, for the z-score, did you guys get negative 0.284?
I got negative 2.57.
I did this wrong. So we're supposed to minus the 3.3,
Minus
or 3.3
Uh-huh.
minus 3.5
Uh-huh.
divided by the 0.078, right? Or
Divided by point, let me find it to make sure I'm not telling you.
we get negative 0.2 divided by let's see.
Yeah, divided by 0.7, and then the 0.7 divided by root 81, since there's 81 people.
0.7 divided by square root 81. So I got negative 2.57.
Yeah, that's what I got. And then you plug it into the applet under the z-score. And then you highlight the blue on the left side of the left line.
Oh, just the blue of the left side?
Yeah.
So it's just 0.0051.
Yeah. But then it's 3 decimal places, so it's 5. And then you could just take 1 minus that number, and that'll give you the answer to question 14.
so
0.9949.
Yeah, so it rounds up to 995.
Right. United States.
So 1 minus
the 0.005.
0.005.
Yeah.
Okay.
Okay, we ready for question 15?
Yeah, I'm ready.
Yeah, I'll read it real quick. The United States Coast Guard assumes that the mean weight of the passengers in the commercial boat is 185 pounds. The previous value was lower, but was raised to after a tragic boating accident. The standard deviation of passengers' weight is about 26.7 pounds. The weight of a random sample of 48 commercial boat passengers was recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have the weight that is an extreme, weight that is an extreme or more extreme, either above or below the mean that was observed in the sample. Note as an extreme or more extreme values that we are not only interested in values that are lower than the ones we observed, but also the values that are as far away from the mean as ours in the positive direction. So we're going to find the standard, we'll find the z-score, and then we can use the applet to find whatever's on the outside of the one standard deviation, or whatever the deviation is.
Yeah, I'm just trying to figure out what it where it wants the blue.
Oh.
It says more extreme, so they want you to shade to the right.
Yeah, to the outside of the red bars.
So not in the middle?
Yeah, not in the middle, because it's saying...
Not in the middle.
Yeah. Find the probability...
Because it says more, not the same as or greater.
Yeah, find the probability that a random sample of passengers will have a weight that's an extreme or more extreme example.
Oh, okay.
And then it says, note, as extreme or more extreme means that we're not only interested in values lower than the ones we observe, but also far away from the mean as in the positive direction. So it can be really light or really heavy.
Okay. So I did put that in the applet, and I got 0.055. Someone just texted me and said it's snowing right now.
That's gross.
No way. Dude.
All right, what did you get?
I got 0.055 or 0.055.
After you plugged it into the applet?
Yeah.
Okay. I was like, that is not what I got.
Here, I'll submit the quiz really quick. Okay, so we didn't get question 4 right. Or 5.
So what did you get for 15? Sorry.
Hold on.
15, we got 0.055. But questions 4 and 5.
We got wrong. So if someone wants to do...
so 5 would probably be the normal distribution, right?
Yeah, maybe.
So did you get everything else right, Alexa?
Yeah, everything else was right besides those 2.
All right, I'm going to do this. Let me just turn it in and see what happens. I changed those ones, though.
Okay, I was like, well, that was dumb of you, but okay.
Yeah, okay, 4 is the distribution of sample means bar X, but 5 is not the normal distribution.
Yeah, I'm thinking it was going to be the law of large numbers.
Okay, it's got to be the law of large numbers.
So Jared or Charity, if one of you guys want to submit that.
I'll submit the law of large numbers.
Okay.
And then should I submit?
No, don't submit anything right now. Okay. Sorry, that was like.
No, you're fine. I understand. You're perfectly fine, Alexa. Okay. Sorry. What?
Yeah, it's the law of large numbers.
Okay.
Okay.
So I'm gonna attempt again.
All right.
Here, Luke and Charity, as I go through the questions, I'll read it out loud because I took pictures of it.
Please.
So.
All right, I'm ready.
Okay, let me start it.
Do you want me to give you the answers, or because I got 100 on mine?
Oh.
Okay. Yeah. Question 3. What's question 3?
0.175.
Okay.
4 is the distribution of sample means bar X. 5 is the law of large numbers.
Yep.
6 is
1.045.
7.
7 is 1.148.
8.
8 is 2.338.
9,
9 is 0.0097.
10, approximately
10 is approximately normal.
11,
11 is 3.5.
12,
12 is 0.078.
13,
Is 0.005.
14,
0.995.
and 15.
15 is 0.055.
Okay.
You said on question 4 it was the first one, right?
No, it's the
On
bar
question
X,
4,
the middle one.
it's the bar X
Oh,
one.
okay. Glad you told me.
Okay.
Oh, shoot. Wait, don't turn it in yet, Alexia.
Okay.
I missed one. 7. I didn't get 7 right.
7 was 0.148.
Oh, okay. I did 1.148.
0.148. Okay.
So it's not 1.1. It's 0.148.
Yeah,
Dang.
sorry.
No, it's all good.
Okay. I'm good if you guys are.
Okay, sweet.
Okay.
I'm good.
I'm good.
Talk to you Tuesday.
Okay, sounds good.
Yep.
Have a
All right,
good
see y'all.
weekend. Bye.
All right, you too.
All right,
Bye.
you too. Bye.